Right there, this is exercise 6A.2, looking at binomial expansions again. Last time, of course, we looked at this type of question where n, it said, does no longer need to be rational. It can be any old number. So, for instance, this is the kind of question we saw. We saw 1 plus 3x to the 2/3, and this is why it's different from the stuff we learnt at year 12. In year 12, that would have been a 3 or a 2 or a 7 or something. A nice positive integer, but now we've got this horrible power. And I remember showing you in the last video that we write n equals 2/3. We write what the x really is, even though it says x in my formula. We know here it's 3x because of this. So I use 1 plus nx formula. I'm going to write 1 plus n, which is 2/3, times by the x. How many terms? It wants me to do 4 terms, plus n times by n minus 1, which if you're doing a calculation is minus 1/3, divided by 2 factorial times by the 3x squared. So this is where we've got to get our head around it. It says x squared, but we know we've got to write 3x squared, plus by 2/3 times by minus 1/3. Now I've got to take another 1 off this, which is minus 4/3. You keep on taking 1 off each time. Divided by 3 factorial times by the 3x cubed. And again, although it says x cubed, we know it's 3x cubed. So this gives me 1 plus, well, 2/3 of 3 is 2x, sorry. The next one, now I'm just looking at it, I know the answer is going to be a minus because they've got a minus there. So I've got to do 2/3, so that's 2/9 I times it by that. Divided by 2 is 1/9 again. And then I've got to times by effectively, this is the bit where people go wrong. So if you type this in your calculator, times by 9, not 3. I reckon that's minus 1 you get, so minus x squared. And what's this become? This is getting a bit tricky. I'm going to do this with my calculator. So it's 2/3 times by 1/3 times by 4/3 divided by the 3 factorial, which is 6, and times by, and again this is where I'd highlight to you, times by 27 because it's 3 cubed. And the other thing I'm going to need to just suss is the fact that it says minus and minus 6 plus a plus, and I get 4/3 of x cubed. I always get asked about validity. Validity is mod x is less than 1. My x is really 3x. Alright, mod 3x is less than 1. Or mod x. And I move the 3 over, is less than 1/3. So mod x is less than 1/3. Is that what I got? Yes, it is. So that works as well. Now, all I would highlight in your mind is the fact that this is minus 1/3, which I'm talking about because of this, and this is 1/3. So between these two values, the approximation should be roughly right. By the approximation, this is my red curve. This is what I start with. And this is my blue curve. This is what I want to pretend it is. And you'll notice the two are very, very similar between minus 1/3 and 1/3. So my approximation is a good approximation between these points. Over here, it's a rubbish approximation. I don't care about that. All I care about is between these 2 points. Let's have a look at some harder ones. And they are harder because you'll notice in this example it says 2 plus x. So up to now everything's said on these harder examples with dodgy powers, not the stuff we did earlier in year 12. But on these new ones which we've seen in exercise 6a, n can be any dodgy power. And you must always have these with a 1 plus something, or it could be 1 minus, but it must be a 1. And ours isn't, it's a 2, so I've got to make it a 1. And the way I make it a 1 is take out 2 as a common factor. So 2 times by 1 will give me the 2, and this is the one that you just got to be a bit careful of. It becomes x over 2, so when I times that, it still works. This, of course, is to the power minus 3, and this is the point I want you to say to yourself, oh, and must remember then, that 2 is really to the minus 3 as well. And so I get 2 to the minus 3 at the front, as well as this bracket to the minus 3. And that's what people go wrong. 2 to the minus 3, by the way, is 1 over 2 cubed, which is an 8th. So this is an 1/8 of this thing here. Now this we do in the normal way. So I'm going to write my n is minus 3 there. And my x really now is x over 2. Although it didn't start off that, it is now. That's the bit I'm expanding. So I'm going to use my 1 plus nx formula at the top. 1 plus nx. That's minus 3 times by the x over 2. And he wants me to go to x squared, so I just need one more term. Plus minus 3 times by minus 4. I'll take off one more. Divided by 2 factorial times by the x over 2. Better put in a bracket this time, squared. So I need an 8th at the front of this, which I should keep for a bit longer. 1 minus 3 over 2x. What's this guy? I always like to do it in my head. You might want to just type it into your calculator. But 3 4s are 12, divided by 2 is a 6. And don't forget, you're dividing really by 2 squared, because of that there. That's where people go wrong. So I said 6, it's minus something minus a plus, so it's 6 over 4, because of the 2 squared x squared. And I can multiply out by an 8th now. I get an 8th minus 3/16 x, and I reckon it's plus 3/16 x squared. Validity wise, what we've got? Well, we've got mod x over 2 is less than 1. So if I rearrange that, mod x is less than 2. And yes, it is. Example 2. So what have I got now? I've got a very similar question. I've got 8 minus x to the third. 8 minus x to the third, I've got to do a similar trick. I've got to take out 8 as a common factor. So I write 1 minus. Now, this is the bit that people get wrong. They forget the over 8. And they also get wrong the fact I write that to the third must mean I write the 8 to the third as well. Now, 8 to the third, if you do it, is actually the cube root of 8, which is 2. So this is 2 lots of something. And now I expand this using my normal rule. So my n is a third. And my x is really, don't forget the minus matters. So I'm going to write minus x over 8. So using my 1 plus nx formula at the top, it's 1 plus n. But one thing that you probably need to point out to you is the fact that when we did this in year 12 early work, on the simple binomial expansions, whenever there's a minus, we was able to say, we know it's going to get plus, minus, plus, minus, plus, minus. But here we can't. It's more complicated, so we better not do that trick, because it won't work. So here I'm going to write 2 in brackets 1 plus, and I'm just simply going to write n is a third, so I'm going to use the formula, just follow the formula, times by the x, which is minus x over 8. Plus n is a third, times by n minus 1 is minus 2 thirds, over 2 factorial times by minus x over 8 squared. And it says I need up to x cubed, so I need an extra term. Plus a third minus 2 thirds. Take another one off, it's minus 5 thirds. All over 3 factorial times by minus x over 8 cubed. So what have I got? I've got 2 lots of some bracket, and that bracket will be 1 minus, because of that, I reckon x over 24. These numbers aren't going to look pretty. Plus, is it plus? But actually it's a minus, because I've got 1 minus there, I've got a minus there, but it's squared, so it's like 2 of them. So my answer is going to be minus. You're welcome to do this on your calculator. I'm just going to, so I've got a third times by 2 thirds. Now, divided by the 2 factorial, which is 2, and notice some people here would divide by 8. It's actually 8 squared. So I'm dividing by 64. And I got 1 over 576, so I'm going to write x squared over 576. Not very nice. I think this is going to get even worse. So the next one, first of all, is it plus or minus? Minus, minus, and because it's minus x cubed, that's like 3 of them, 4, 5 of them. So overall negative because it's an odd number. So how many x cubes have I got? I've got a third times by 2 thirds times by 5 thirds divided by 3 factorial, which is 6. And divide by, this is where people go wrong, it's 8 cubed. So 8 divided by 8 cubed. And I get, ooh, not very nice. It didn't look nice, but that's worse than I expected. 5 over 41472 x cubed. Now all of these need to be times by 2, which gives me 2 minus x over 12 minus, I reckon that's 2 over 576, which is x squared over 288. And this next one, I'm not going to try to do it. I'm going to times it by 2 on my calculator, and I get 5 over 20736x cubed. Yuck. Validity-wise, now you can ignore the minus because we're modding it. So validity-wise, x over 8 has to be less than 1. Or said differently, mod x has to be less than 8 when I move it over. Yes, and that looks vaguely right. I want to do this example. This is an integration. So if I just crack on with this, there are a couple of questions on the textbook with these on it. Now, this is actually different. I nearly did the bracket there, but I can't quite yet do the bracket. It says 1 over 4 plus x squared. But you should remember 1 over means to the power of, so I'm going to 4 plus x squared to the power of minus 1. Important that you suss that. Now, of course, I can't do it because it says 4, so I have to take out that 4 as a common factor. Right, 1 plus, but weirdly, it has to say 1, but this bit can say anything I like. So this says x squared over 4. It doesn't just have to be x. But that's to the power of minus 1. Oh, this is when I remind myself that that is also to the minus 1. 4 to the minus 1 is a quarter. And my n is minus 1, and my x is really x squared over 4. So that gives me, use my 1 plus nx formula, 1 plus minus 1 times the x squared over 4. How many terms it want? It wants 3 terms. Okay, I've got 2 so far. Plus minus 1, and minus 1 would be minus 2 over 2 factorial times by x squared over 4 squared. That gives me a quarter of 1 minus x squared over 4 plus minus times a minus plus 2, that all goes. I think it's just x squared over 16. And if I times it by a quarter, I get a quarter minus x squared over 16 plus x squared over 64. Validity, yes, it wants validity. Well, I had x squared over 4. Modded is less than 1, so I reckon that means x squared modded is less than 4. I reckon mod x is less than 2. So all of that looks right. Now the last bit says do an integration. So it says it here. It says integrate from 0 to 1, 1 over 4 plus x squared. Now look, you can't do this yet. So we need an alternative method for doing it. And the obvious thing is to say, well, a bit 1 plus 4x, 1 over 4 plus x squared can be written, we now know, within a certain degree of accuracy, that. So I can change this, even though it's horrible and I can't do it, I can change it to this. And this is why we do it. We write it so we can do other stuff. And this is between 0 and 1. So if I integrate it, you remember the rule, add a power, divide by the new power. 16th over x cubed over 3 plus a 64th x to the 5 over 5. And if I do that, I reckon it's a quarter x minus x cubed over 48 plus x to the 5. That sounds like 320 to me. That's between, of course, the boundaries of the limits 0 and 1. Now if I chuck 1 in, I get a quarter minus a 48th plus a 3/20th. And luckily, actually, if I put 0 into that, I get 0 out on all of them. Oops. So if I just type that into my calculator, I get, yeah, we've got time, 0.25 minus a 48th plus a 3/20th. I get 223 over 960, which is that same answer as that. Good, so that works. Now a couple of things. Finish off for me exercise 6A. They're the questions I want you to do. And I'd also like to point you to this. This is an extra example for you, for those of you who just want an extra practice question. Have a go at that one. there's the answers. So hopefully you've seen the answers and the question. And that then is the exercise to do. Best of luck, and I hope that's okay for you.